In the previous session, we looked into that how the secant or how the slope of the secant is looked upon, how that secant is converted to a specific point by extending the limit of the change in the horizontal or the x direction tending or moving towards 0. Welcome to lecture 3.3. Herein we are going to talk about secant and the tangent, the slope of the secant between 2 points and slope of the tangent at that particular point, and try to figure out what is the difference between the average rate of change and the instantaneous rate of change. Rate of change between 2 points and rate of change at that particular point. So let us look to a scenario that there is a flask. You've seen in the example, there is a flask which is being heated from the bottom, and now we are recording the temperature at this flask. If I look to a scenario that how this is going to vary, this would be the time when we started heating the flask and the water starts getting boiled, and this side let there be temperature. Now this is the boiling temperature. Say for example that this is the T2 kind of scenario. When we started heating, it cannot be 0, means maybe in some of the countries it can be 0. But if you look to a general scenario, let it start from T1. Now this T1 is nothing but the temperature of the room or the room temperature. Now if I look to the scenario that how this is getting actually the heat and the temperature is getting increased is somewhat this. Means after this time, that is time T, it has reached to the boiling temperature. See, looking to this scenario and the present or the previous discussions we had. Now let this point be P, the starting point, and then this be the end point, that is Q. If I am looking to the slope, of the line joining this P and Q, this is nothing but delta T, that is the change in temperature or the output, and this is nothing but delta small t, that is the change in time. So the slope or the secant slope, that is secant, is nothing but P and Q. The slope of this secant will be equal to m sec, and that will nothing be equal to delta t divided by small delta t. This is the change in the temperature, change in temp, divided by the change what has happened in terms of time. Now, as we discussed earlier, that at any given point of time, if I intend to know that what is the change, let this be the point R. Now I need to look to this T, this change in T or delta T, say for example from this point to the point of boiling. If I am looking to this scenario, now it is at R, that is nothing but tangent. I am looking to tangent, and this is not P and Q, this is not between 2 points, this is at point R. Now this slope would be m, or the slope of the tangent, as we have already known that this is going to be limit delta t, the change in time, this time tending to 0, means we are reaching to this particular scenario and it is actually boiling down and coming to this particular point in time, and the change would be what? Delta T, that is change in temperature, divided by delta change in time. Now this time we are actually reducing it to 0 so that we reach to this particular point R. Speaking in terms of mathematics, the secant always gives you the average rate of change. Average rate of change. Whereas the tangent would always give you the instantaneous rate of change. Now what is the basic difference between secant and tangent? Let me draw something like this over here. Say for example, this is the time t over here, and you are basically, as I have drawn earlier also, that you are driving a car. Now this is the time t, this is your start point, and this is the distance which you have traveled. Say for example, this is the distance. Now you have traveled something like this to reach to this particular distance. If I draw a line between these 2 points, the start point I'll call it as S, and this becomes the end point. If I'm looking to the slope of the point of the line which is actually joining the start and the ending, I'll be looking to the average speed. Whereas if at a particular point of time I intend to assess the speed, that is maybe a point in between, maybe we'll call it as R, then slope, this is not between 2 points, this is slope at a specific point, will give you the instantaneous speed. So when we want to look to the average scenario of the rate of change, we go for the slope of the secant. Now this is the secant approach. But whenever we want to go in for the instantaneous approach, we always go in for the tangent, the slope of the tangent, not just the tangent, the slope of the tangent at that point. Now look to a situation wherein at this particular point, maybe Q, at the slope of tangent at Q, slope of tangent at Q is 0. This is a very specific situation wherein the slope at a given point is 0. Means at this particular point the behavior of the tangent is horizontal, and now this is a very specific behavior wherein it is supposed to be constant. See, in the coming lecture we are going to talk about derivatives. We already know that if this is a plant which is growing, the rate and the behavior of the change in the height of this plant or the growth of this plant is very well depicted by a function. We all know what function is. Now, if I want to take the average rate of growth of this plant, maybe after 1 year, what is the average rate of growth? We are going to talk about the secant. But instantaneous for day after tomorrow, what is going to be the growth of this plant can only be found out by derivatives. We already know about this, that is nothing but the tangent slope at that particular point. So in the coming lecture we are going to talk about derivatives and what is the role of derivative when we are going to look into the instantaneous rate of change, not the average rate of change. I'll see you in the next lecture. Thank you.